In this video, we're going to solve angle problems with algebra. All right, so if I look at my first picture here, it asks me to find the number of degrees in each angle in the picture. I have this angle right here that was labeled as A. I have this angle here that was labeled as 4A plus 5. The key to being able to solve this problem is recognizing the angle relationship that we see in the picture. If I take this angle A and this angle 4A plus 5 and I put them together, notice that they have formed a right angle, meaning that the measures of these angles are complementary. Complementary angles always add up to 90 degrees. So if I take the angle labeled as A and I add it to the angle labeled as 4A plus 5, their sum has to be 90 degrees. I'm going to simplify A and 4A to make 5A plus 5 equals 90. And now this is just a two-step algebra problem. I'll start by subtracting 5 on each side. That means that 5a is going to be equal to 85. And then if I divide each side by 5, then I know the value of a is going to be 17. So this angle right here that was labeled as a is 17 degrees. To get the angle that was labeled as 4a plus 5, I'm going to take that expression and I'm going to substitute in a's value of 17, and then I'm going to use the order of operations. 4 times 17 is 68, and if you add 5 to 68, then you get 73. So this angle here would have to be a 73-degree angle, and I can check to make sure that this is right by adding these two angles together. 17 plus 73 equals 90, and it should because these angles were complementary to each other. In my next picture, it's a similar problem. I have an angle labeled as 2x minus 15. I have another angle labeled here as 3x plus 10. I need to figure out what the measures of those two angles are. If I take those angles and I put them together, notice that they have formed a linear pair. They are supplementary to each other, meaning that their measures have to add up to 180 degrees. So if I take the angle 2x minus 15 and I add it to the angle 3x plus 10, those measures have to add up to 180 degrees. We'll simplify this left-hand side. 2x and 3x makes 5x, and negative 15 plus 10 is negative 5, so 5x minus 5 equals 180. And now we just have a two-step algebra problem. I'm going to start by adding 5 to each side. Doing that means that 5x is equal to 185. And then if I divide 185 by 5, well, I'm going to divide each side by 5 actually. That means that x is going to equal 37. Notice neither of these angles is just labeled as x, so I have to substitute to get both of the measures. So if I have 2x minus 15, I'm going to substitute in x for 37. And now I'm going to have to multiply first. 37 multiplied by 2 is 74. And then if you take 15 from that, you're left with 59. So this is going to have to be a 59-degree angle. All right, now I'm going to take the angle 3x plus 10, and once again, I'm going to substitute in 37 for 10. If you multiply 37 by 3, you get 111, and adding 10 to that gives you 121. So this is a 121-degree angle. And once again, I can check to make sure I did this right by adding these numbers together. 59 plus 121 does equal 180, as it should, because this was a linear pair, and these angles were supplementary to each other. Let's calculate some more angle measures algebraically. All right, in this picture, I have this angle labeled as A, and then this angle labeled as 2A minus 6. And if I notice in the picture, together they have formed a right angle, making their measures complementary, so they have to add up to 90 degrees. If I take the angle A and I add it to the angle 2A minus 6, again, their sum has to be 90 degrees because they are complementary. A and 2A simplifies to make 3A minus 6 equals 90. And then I'm going to add 6 to each side, meaning that 3A is equal to 96. And then if you divide each side by 3, that means that A is going to be equal to 32. So this angle just labeled as A is 32 degrees. To get the angle here labeled as 2A minus 6, let's make A 32. So 2 times 32 minus 6. 2 times 32 is 64. And if you take away 6, then you're left with 58. So this is a 58-degree angle. And 32 plus 58 does add up to 90, so I know I've done this problem correctly. In my next picture, I have this angle is 2x minus 19, and this angle is 3x plus 4. Together, they have formed a linear pair. This is an example of supplementary angles, meaning that the measures of the two angles have to add up to 180 degrees. All right, so we're going to take the angle 2x minus 19 and add that to the angle 3x plus 4, and their measures add up to 180 degrees. 2x and 3x makes 5x. Negative 19 and 4 makes negative 15. So now our equation says 5x plus 15, minus 15 equals 180. And I'm going to add 15 on each side first. 5x, therefore, is equal to 195. And now if we divide 195 and 5x both by 5, x is going to have a value of 39. Now again, I don't know what either one of these is yet, so I'm going to have to substitute in x's value. So for 2x minus 19, x becomes 39. All right, and if we double 39, that gives us 78. And 78 taking away 19 leaves us with 59. So this is a 59-degree angle. Okay, and now we'll substitute into 3x plus 4. X again was equal to 39. All right, and then if you multiply 39 by 3, you get 117. And adding 4 to that is 121. So this is a 121-degree angle. And if you add 121 with 59, you will get 180, as you should, because these were supplementary angles. In our next picture, we have vertical angles, and I know that because we have two lines that have intersected. Remember that vertical angles are non-adjacent angles. They're across from each other from the point of intersection. And vertical angles are always congruent to each other, so their measures are going to be equal. In this example, it says to find the value of each variable. Notice here I have the variable a, while down here I have the variable n. All right, I'm going to calculate each of those, and I'm going to use the fact that I have congruent vertical angles in this picture. So let's start with the variable a. This angle labeled as 3a minus 12 has to be equal to 162 degrees because these are vertical angles, and vertical angles are always equal. They're always congruent to each other. So 3a minus 12 is equal to 162. Let's add 12 to each side. That means that 3a is going to equal 174. And then we're going to have to divide each side by 3. And when we do that, a is going to have a value of 58. Now I want to try to figure out the value of n, and I'm going to use a very similar method. All right, this angle, 7n minus 80, has to be equal to 18 degrees because, again, these are vertical angles, and vertical angles are always congruent to each other. So we'll start by adding 80 to each side, meaning that 7n is going to be equal to 98. And then if we take 98 and 7n and divide each of those by 7, then the value of n has to be 14 in this example. Let's look at some word problems that involve algebra and angles together. In our first word problem, it says that an angle is 6 less than twice its complement. Find the angle and its complement. All right, so we're looking for two different things in this problem. We're looking for the angle measure and the measure of the complement of the angle. So the first thing I'm going to do is write some let statements. I'm going to need two of them, one for each of the angles that we're talking about. Now, they tell me that an angle is 6 less than twice its complement, but they don't tell me anything about the complement. So I'm going to say let C equal the complement. All right, so C represents the measure of the complement. For my original angle itself, the angle is 6 less than twice the complement. So to do twice the complement, I need to do 2C. And then to be 6 less than that, I'm going to have to subtract 6. So 2C minus 6 is going to represent the angle. Okay, so those are the let statements representing the angles in my problem. And I'm also going to draw a picture of this problem so that I can visualize what it's going to look like. Keyword here is complement. Complementary angles are two angles that will form a right angle, meaning that they will add up to 90 degrees. So I might have a picture that looks something like this. Right? One of my angles I've called C, and the other one I've called 2C minus 6. Together, these angles make 90 degrees. So I'm going to take the angle labeled as C, and I'm going to add it to the angle labeled as 2C minus 6. Their measures together are 90 degrees. C plus 2C simplifies to make 3C minus 6 equals 90. And now I'm going to add 6 to each side. 3C is going to equal 96. And then if I divide each side by 3, that means that C is going to equal 32. All right, so the complement angle, this angle right here, C is going to equal 32 degrees. The other angle, which was 2C minus 6, to figure that out, I'm going to substitute in 32 for C. All right, so 2 times C minus 6 becomes 2 times 32 minus 6. 2 times 32 is 64. And when you take away 6 from that, you're left with 58 degrees. So I now know that the angle measures 58 degrees. And I know that because the angle itself was 2C minus 6, and I just calculated that. The angle measures 58 degrees, and the complement, which was the angle that I labeled as C, the complement measures 32 degrees. And if I add 32 with 58, I'm going to get 90. And that makes sense here because the two angles together have to add up to 90 degrees. In our next problem, we're told that the measure of an angle is 20 degrees less than 4 times the measure of its supplement. Find the angle and its supplement. So again, two different angles that we're looking for. So I'm going to make two let statements in the first part of my problem. All right, and reading carefully, I know something about the measure of the angle, but I don't know anything about the supplement. So let's say let S equal the supplement. All right, S represents the measure of the supplement of our original angle. And if S is the supplement and the angle is 20 degrees less than 4 times the measure of the supplement, 4 times the supplement is 4S. So let 4S, all right, and then 20 degrees less than that, minus 20, this is going to represent the measure of the angle. All right, the angle is 20 degrees less than 4 times the measure of the supplement. Let's again draw a picture so that we can visualize what this looks like. All right, supplementary angles are two angles that will form a linear pair if they are adjacent to each other, something like that. All right, so one of my angles, my supplement, I'm going to call S, and then the other one I've called 4S minus 20. Together, these angles will add up to 180 degrees because they form a straight line, a straight angle. So the angle S plus the angle 4S minus 20 adds up to 180. I'm going to simplify S with 4S in order to make 5S minus 20 for 180. And now I'm going to have to add 20 to each side. Plus 20 plus 20. 5S is equal to 200. And now if I take 200 and 5S and divide them both by 5, S is going to have a value of 40. All right, so my S, my supplement in this case, S is equal to 40 degrees. And my other angle, 4S minus 20, to get its measurement, I'm going to substitute in 40 for S. So this becomes 4 times 40 minus 20. 4 times 40 is 160, and 160 minus 20 is 140 degrees. And I know this is right. 40 plus 140 is 180, as it should be, because they were a supplementary linear pair. So I can say that the angle, all right, and the angle again I've called 4S minus 20, the angle measures 140 degrees, and the supplement measures 40 degrees. All right, and then in our final problem, we're told that in a pair of complementary angles, the larger angle is 3 times the measure of the smaller angle. Find the measure of each angle. Okay, so a larger angle and a smaller angle are the two angles that we're looking for here. So we're going to make two let statements. Okay, and for one of them, let x equal, well, which one do we know nothing about? Well, I know the larger is 3 times the smaller, but I don't know anything about the smaller. So let x equal the smaller angle. And if x is the smaller angle and the larger is 3 times the smaller, then 3x is going to be the larger angle. Okay, we'll make a quick sketch to see what this looks like. Again, complementary angles are two angles that are adding up to 90 degrees. So they would create a right angle when we put them together. One of them is x, the other one I've called 3x. So for my equation, x plus 3x equals 90 in this example. And then if I add x with 3x, I get 4x. And then to get the value of x, I just have to divide each side by 4. All right, well, 90 divided by 4 is 22 and a half. So my smaller angle, which is x, that angle is 22 and a half degrees. My larger angle, 3x, is going to become 3 times 22 and a half. And if I multiply 22 and a half by 3, then I get 67 and a half degrees. So I can say x, which is my smaller angle, the smaller angle, the smaller angle measures 22 and a half degrees, and the larger angle measures 67 and a half degrees. And again, I know I've done this right because 67 and a half plus 22 and a half adds up to 90, and complementary angles will always have a sum of 90 degrees.